Okay, everyone, here's a video. I'm going to do two of more of the standard practice problems. So I'm going to do one rectangle problem with area, and then I'm going to do one of the Pythagorean theorem problems. Okay, so I just jotted down a couple notes. That's why it looks weird. But what this means is a length is of a rectangle is 4 meters more than the width. Okay, so if the width is this, then the length is 4 more than the width. So I can call this the width plus 4. Okay, and so I can label that. And I know all the problems aren't like that, but if this is the width, this has to be 4 more than the width. Okay, so then the other thing I know about this is that the area is 117. So we think of a formula that we know about rectangles and relates area, length, and width. And that's area equals length times width. Okay. And so in this case, the area is equal to the length, W plus 4, times the width. And we know what the area is. It's 117. I'm just going to rearrange this to look a little better. Okay, huge mistake if you set these both equal to 0 or equal to 117 and call it a day. That's not going to work. We have to get this equal to 0 before we can use factoring. Hopefully factoring can work. This is not going to be an undoing situation because we have multiple W's. Okay, so I'm going to keep this side the same and I'm going to distribute, and I get this. And then remember to try factoring, which hopefully it works. I have to get this equal to 0. So minus 117 minus 117. And I get 0 equals W squared plus 4W minus 117. Okay, so that becomes a problem that we can hopefully factor. Okay, so if we look at this now, we need to think about, I'm going to get my box out because I don't happen to know what multiplies to 117 and adds to 4 right now. I just don't. So I'm going to look at this. This is going to be W squared. And then this number goes down here, negative 117. Okay. And what I know then is I have to find something that multiplies to this, which is negative 117W squared, weird, and adds to this, which is 4W. So I want to start thinking about things that multiply to 117. I have no clue. So I'm just going to get my trusty calculator and start trying things. So if I think of 117, well, I know it doesn't divide by 2 because it's odd. What about divided by 3? Oh, that works. Okay. So 3 times 39 works. And I could make negative 3 or negative 39. Those don't add to 4. Now, if I do 117 divided by 4, nope, it's a decimal. 117 divided by 5 is not going to work because it doesn't end with a 0 or a 5. Let's divide by 6. 6 is a decimal. 117 divided by 7, nope. 117 divided by 8, nope. 117 divided by 9, yay! And that's going to be either negative 9 times 13 or 9 times negative 13. Okay, and so when I look at this, this adds to 4W. Okay, so 0 equals, oops, sorry, getting a little ahead of myself. So I'm going to put let's put the negative 9 here. It doesn't really matter. Negative 9W and 13W. Okay, so I'm going to factor a W out, left with a W here. And if I take a W out of this, I get negative 9. Now, if I take a negative 9 out of this, I already know I get a positive 13. And when I set both of these equal to 0, I get W equals positive 9 and negative 13. Is it possible for the width to equal a negative number? Absolutely not. That's not making any sense with a rectangle. So that gets thrown out. And so the width is then 9. And what does that make the length? Well, the length is 4 more than the width. So it makes that 13. You can always double check, is 9 times 13 117? And the answer is yes. Okay, so there's that problem. So the whole idea here is you're coming up with an equation and subbing them in. I can't start with this equation. I have two missing variables because I knew A. That doesn't work. So I come up with another equation to substitute it in. That's like the example in the slideshow. Okay, let's try a Pythagorean theorem problem. So now I know Pythagorean theorem is a squared plus b squared equals c squared, where c is always the hypotenuse. So let's try and label the triangle that we get from the information in this problem. So the length of one leg is 2 feet. Well, just how I drew it, it looks like this one's smaller. I guess I don't know for sure the other one. Oh, shoot, I should probably keep reading. Length of one leg is 2 feet longer than the width. Okay, so I should actually do W plus 2 because it's 2 feet longer than the width. And then we'll call this W. It doesn't really matter that they don't look to scale. If you want, you can switch them. It doesn't matter. And then it says that the hypotenuse is 10. Again, I was paraphrasing, right? I took a problem and I shortened it rather than writing it all out. Okay, so what equation do I have that represents the three sides of a triangle? Well, the equation I have is a squared plus b squared equals c squared. And what I'm going to do is I'm going to plug everything I know in. Hopefully I only have one variable and then I'll be able to solve for it. So I'm going to call this A. W plus 2 squared plus b squared, w squared, equals c squared, which is 10 squared. And then I try and simplify whatever I can simplify. W plus 2 times w plus 2. Don't break your math teacher's heart and call that w squared plus 4. It's not. You've got to simplify it. Okay, I've got that. Now I'm going to distribute all this out. W times W, W times 2, 2 times W, 2 times 2. If that was confusing, watch me do that again. I'm distributing everything. Another way we did that was we would do W2, W2, and then we'd find the area of each box. Plus W squared, which was that, equals 100, which was that. I combine all this good stuff up, okay? And if I combine all that loveliness, I get 2w squared plus 4w plus 4 equals 100. Okay, now you might remember from some of the problems we did, because I'm solving this, I could factor out a 2. And again, trying to get this simplified if I can, actually. Whoops. So I'm going to divide both sides by 2. Now you might have thought to subtract 100 first. I didn't think of that, but I'm going to have to deal with that in a sec. So if I divide by 2, I get w squared plus 2w plus 2, right? Because the 2 was factored out, equals 50. I can't factor this unless it's, well, hopefully I can factor it, but I've got to set it equal to 0. W squared plus 2w minus 48 equals 0. Okay, I'm going to try factoring. We have other methods, but I'm going to try factoring. So I need something that multiplies to negative 48w squared and something that adds to 2w. If I think about the things, I'm going to jump around a little. 48, I think 6 and 8 work. Let's look. Yeah, I double checked. Okay, so I could do negative 6 and positive 8 or negative 8 and positive 6. And if I think about which one of those adds to a positive 2w, it's this guy. And so then I get negative 6, 8. And I factor out each of my rows. Oops. And 8. And I double check, and it works. Okay, put my guys in here. W plus 8. W minus 6. W equals negative 8 and positive 6. Does it make sense to have a negative width in my picture? Absolutely not. So that guy's out of here, okay? But what you'll notice is we kind of see that guy, or at least a similar guy to it again. So if my width, it says find the length of the legs. So this leg is 6. And then if this is 2 more than 6, it's 8. So those are my lengths of my legs. Oops, sorry. Okay. So we're taking, basically the only difference between this and what we had been doing is interpreting the problem, which, if I'm being honest, is probably the hardest part, but we can all do that. And then we'll get smiley faces on all of our papers. I got to throw a little bit of my dorkiness in there. Have a good day, guys.